Okay, so what I just did was I gave everybody 4 LEDs, and what I wanted to do was I wanted to write a little program that was going to output to the LEDs, and also I wanted to find a nice way to make the LEDs so that they could be wired easily to the Arduinos that you've got. Now your Arduinos, let's see, I've got the LEDs. Your LEDs have 2 pins on them, and you can hold them up and you'll see, this is kind of exaggerated in the picture, but one lead on the LED is longer than the other lead on the LED. And the long lead, that's the plus lead, and the short lead, that's the negative lead. And for reasons I guess that are historic, the negative lead, the short lead, is called the cathode, and the positive lead is called the anode. And if you hook the LED up backwards, it won't work. Unlike, incandescent light bulbs, LEDs have a positive and a negative, and it's so important that you get this right. So important. So what you can do is you can hold up your Arduino Uno, and when you look at it, what you can see, if you hold it up so that the USB connector is on the left, is you can see there's a little yellow light, and that yellow light is right in here. That's what's called an SMD, or surface mount device, and that's a tiny LED. And if you take the long lead, which is the positive lead of your LED, and you plug it carefully into the pin marked 13, and you can kind of see right over in here it says 13, and over here it says ground. Take the short end, put it into GND, take the long end and put it into 13, and your little green LED should light up. Or not. I have it backwards? Maybe I don't have enough power. It's possible I don't have enough power. Tell you what, I'll put the long end into gee, this is bumming my space. I'll put the long end into pin 8 and the short end into pin 9. And then what I'm going to do is I'm going to assert pin 9 to be low and pin 8 to be high. How about that? So to do that assertion inside of the Arduino, you have to bring up the example called Basics Blink. Now Basics Blink is going to work with an LED on pin 13. But what I want you to do is to write a little for loop that goes through pins 13 through I'll say 13 through 1, and sets them up as output. So what I'll do is I'll write a for loop for integer I equals 0. Sorry, I'm going to start with pin 1. While I is less than 14, I plus plus, and I'm going to set up the pin mode for the LED I to be output. So I'll say pin mode I output. So now every pin 1 through 13 will be of output. Then what I'm going to do is I'm going to write pin, now the long end, if you recall, is supposed to be positive, and that'll be pin 8. The short end, which is negative, will be pin 9. So I'll assert pin 8 to be high, and I'll assert pin 9 to be low, and in theory this LED should light. And it is. It's lighting up. So now I'm going to take another LED and I'll plug in the long end to pin 10 and the short end to pin 11. So remember, pin 10, which is the even number, is going to be high, and I'll do a digital write to pin 10 and we'll make it high, and I'll do, to the odd number, pin 11, and we'll make it low. So digital write 11 will be low. Now when I run the program, I should have two LEDs light up at the same time. And there they are. Similarly, I'll make pin 12 and 13 to be even and odd respectively, which means they'll be positive and negative respectively. So pin 11 will be, pin 12 will be my my high, and then pin 13 will be my low. I can remove the delay. That's not needed. Do an upload, and I should have 3 LEDs that are lit, and I do. Now, if you want your 4th LED to work, we can go to pins 6 and 7. We'll make 6 high and we'll make 7 low. So just to neaten things up a bit, digital write for pin 6 will be high, and then for digital write for pin 7 we'll make that low, and now I should have 4 LEDs all lit up in theory, and I do. Now the reason I did it this way was because I really didn't want to have to get a breadboard out and start wiring things up separately. So by straddling adjacent digital I/O pins, I was able to neatly establish a way to wire up my little LED bar graph. What do you think of that? Good, right? Mike, how you doing over there? Good, it works. And everything. So now if I want to, I can go through a count by 2, starting at 6 and going through 12, and alternately turn LEDs on and off in my loop. And in fact, if you think about it, this entire digital write statement right in through here can be moved, let's cut it, and put it into the setup. That way it's executed once and only once. Now when I do my upload, it should still work. And it does. So now in my loop, what I'll do is I'll write a little for loop. For integer I equals, we'll start with 6. That's the 6 LED. Well, I is less than, I guess we go up to 12. So let's do 13. And then I equals I plus 2. So we go by 2's. And then what we can do is we can assert each LED to be off and then on. So we'll do a digital write of I to be low. That'll turn it off. We'll do a sleep for I think it's not sleep. Is it delay? That's it. Delay by a quarter of a second. And then what we'll do is a digital write I, comma, high. So that should turn each one off and then on for 1/4 of a second. And since there's 4 LEDs, I think it'll run through the entire cycle in 1 second, with a 1/4 second blink on each LED. And that should work, in theory. Yep. So I got my little Christmas lights going here. Ain't that cheery? In fact, if I did this with 8 LEDs, it would be like a Hanukkah miracle. Well, maybe not the kind that Moses did, but it's a festival of LEDs. You guys gotten that working? Kevin, how you doing over there? Oh yeah, it looks like it's working. Rich, it's all...
Yeah, I was doing it.
It's working. It's all working, right? Mike?
Yep.
Is it blinking?
Gotta get him a blink.
What's going on? I just wanted to, you know, get you guys thinking about blinking. What do you think? You think it's time to blink? You think? So, I had this idea that now that you've got a nice output display, you would be able to make a little multi-band spectrogram. How fun is that, right? Very fun. But I got a problem. My spectrogram, well, it only works for 8 samples, and these LEDs, well, they're showing me outputs for 4 samples. So what do I do to make my spectrogram work with 4 samples? I got a bunch of bright signal processing students here. You're going to tell me this. I got 4 LEDs, but my DFT works with 8 samples. So what do I do? I could ignore half the samples, right? Because the LEDs only have to correspond to 1/2 of the power spectral density, because it's symmetric. In the center it's DC, and the other 2 subbands are just reflections of one another. Because it's for a real signal, it's always symmetric. So in fact, as fate would have it, 4 LEDs is a perfect number for an 8 sample DFT. How's that? Good, right? Sweet. Yes? Yes. Yes? Yes. Okay. So as I see it, if you're doing the power spectral density and all you want to do is light up the LED when you get to a certain threshold, this will tell you the frequency that you're at. Got that? Everybody good with that? So, here's a big question. Does it make sense to try and implement a fast Fourier transform if you only have 4 samples? Well, on an Arduino, the answer is I don't know. That's the beginning of wisdom. The only way to know where the breakpoint is between a DFT and an FFT in terms of n, the total number of samples, is by doing what? Testing. You have to benchmark it. Yes, absolutely. That is absolutely true. So one of the things that I never did, I mean really never did, or ever saw anybody else do, is benchmark the sliding window DFT against a sliding window FFT. I never did that. Never saw it done before. Now you can see it being done for the Java virtual machine on some of my papers, but I never did it for the DFT against the FFT on the Arduino. There's only one way to tell. We gotta benchmark a Radix 2 FFT and see how it works. How's that? Does that sound like a plan? Yeah? Now, as it happens, a number of people have published some DFTs, and they've made them available for the FFTs, and they've made them available for the Arduino. I never saw anybody publish anything for the DFT. So I never found what we just did in a class published on the web. And I Googled. I mean, a lot. I Googled it a lot. So you've got an opportunity now to either work it on your own, work your own FFT, or to take the DFT that I've got. Now, how'd you guys make out with the homeworks? There was a homework due today, wasn't there? I'm pretty sure. Oh, I forgot my password. What's going on here? Please wait while the module loads. Oh, there it goes. Gee, that takes a while. So here's my biomedical signal processing course, and we had some assignment, right? Haar wavelet transform. Do you guys have any chance to do this? Use an input audio file, do a floating point Haar wavelet transform, show the first 10 samples of the input file, first 10 samples after the transform, and then the first samples of the reconstruction. You need to play the audio file after the decode to test your program. How'd you guys make out with this? Shall we, Rich, can I try your code? Alright, so in theory I should be able to go to the grading center and take a quick looky-loo. Here's yours. Let's go right to yours since you're here. Oh, maybe I just click on that. Down, With comments. Oh, comments.
I put it in
Wow, that looks nice, actually. There's some sample audios in here, so I can just download it and hear it without having to compile it. Cool. Where is that at? Here?
there's
Input data.
after the
Alright, let's hear the input data. That sounds familiar. Now let's hear the data after reconstruction. Sounds great. Can't complain about that. And now, what's this console output here? Oh, that's what you printed out down there, right? So this is an integral power of 2 for n? Cool. And yeah, the formatting's not quite right. But that's alright. And then somewhere in here I got, where's your code?
I'll go back. There's homework 8.
Here it is. It looks real nice. That's cool. Alright, so let's write up a homework for next week. And if you're listening to this and you don't have an Arduino, we got to get together and get you one if you don't have one already. Assignment. FFT. Let's see. I know. Radix 2. FFT implementation. Using the Arduino and an 8 sample ramp for input. Implement a Radix 2 FFT. Show the output before and after the FFT and the inverse FFT. So you're going to implement an FFT and an inverse FFT and IFFT for an 8 sample input. Let's see now. The output will not match the input exactly, but it will be close. Okay. The DFT, as implemented in class, is shown for your reference below. But you will need a DFT, FFT, FFT, and IFFT. Okay? You may use libraries, but be prepared to describe how they are to be used in class. So if you're gonna devise this on your own from scratch, fine. And then you don't have to worry about external libraries. Like I just did everything from scratch just now. But if you want to do something, that uses external libraries, I want to know how you incorporated them into the development environment. And then as far as my code is concerned, what I will do here is copy it and paste it for your reference. Here, paste. And the blinky light code, B-L-I-N-K, the blinky light code is given by, and then I'll put the blinky light code in here. Let's see now, that'll be that. Select all, copy, and paste. And then what we'll do is we'll make the whole thing due next week. This will be out of 100 points. Allow unlimited attempts. Due date. Due 2nd at 2 p.m. And what do you think of this homework assignment? You guys good with this? Alright, so hit submit. And what does that buy you? Cool. So at this point now, I think maybe we're good, unless there are some questions about the homework. So basically, 8-point FFT will be had after we're done. An 8-point DFT will also be had. We'll have them both on the same computer, and we'll be able to benchmark these things for more than 8 points, but we'll do that later, perhaps in class, because I'm going to take one of the FFTs that you guys have implemented, and I'm going to do the benchmarking right here in lecture, and we're going to determine how big a signal is needed before the FFT is warranted. And that is what I have for you for today. Enjoy your Thanksgiving break.